good evening everyone. I welcome you all in a Sapiens Education. Today I am going to teach you NCERT solution of class 11 physics. The chapter which I have taken is laws of motion from 4.11 questions. It is a 4.11 question. A truck starts from rest and accelerates uniformly at a 2 meter per second square. So let us consider there is a truck. Okay. Let us consider there is a truck and it starts from initial velocity is equal to 0 and acceleration is your 2 meter per second square. So this is a acceleration. Now at time equal to 10 seconds, a stone is dropped by a person standing on the top of the truck. So what happens when these trucks are moving at a time t equal to 10 seconds, a stone has been dropped from here. Okay, a stone is dropped like this. Okay, so they are asking me that what is the velocity and acceleration of the stone at a time t is equal to 11 seconds. So first of all, as this stone has been dropped, so what will happen? Since its initial velocity is in horizontal direction, as soon as stone is dropped, so it start moving and it is following the projectile motion. Why? Because as soon as you have dropped the stone, so there are two types of force acting here. So there is a horizontal velocity and the one force due to gravity. And due to gravitational force, what happens? It start moving in a projectile motion, right? So we have to find the velocity at 11 seconds. So at 10 seconds, what is the velocity? At 10 seconds, velocity is v is equal to u plus at. Okay, so since here acceleration is 2, time is 10, so this will be 20 meter per second. Okay, so at a 10 second, now what will be the at 11 seconds? So definitely it will follow the projectile motion. So at 11 second, what will be the velocity? So at 11 second, there are two type of velocity, right? There will be a horizontal velocity, that is velocity in x direction, and there will be a vertical velocity, that is velocity in y direction. As stone is being dropped, so no force is being acting in a horizontal direction, so velocity at x direction will be 10 meter per it will be only 20 meter per second, right? So this will be 20 meter per second, right? Now what is the velocity at in a y direction? As soon as stone is dropped in 10 seconds, so at 11 second we want velocity. So time within 1 second, what is the velocity Vy? So Vy will be equal to u plus gt, because acceleration due to gravity is g. So since u is initially in downward direction, the velocity is 0. So this will be how much? So g is your 10 and time is your 1. So velocity at y direction is 10 meter per second. So you have got velocity at y direction as 10 meter per second. So what will be the resultant velocity? So resultant velocity will be equal to root under vx square plus vy square. So can we write here root under vx square means 20 square plus 10 square. So finally you will get root under 500, or we can write here 22 point something 5 meter per second is okay. So velocity, we have got the velocity, right? Now I am talking about the acceleration part. So part 1. So acceleration, there is no acceleration in horizontal direction, only acceleration which is in a vertical direction. So acceleration is equal to acceleration due to gravity, that is equal to 10 meter per second square. Okay, so I hope you have understood this question. So I will go for a next question, right? Now, question mark 4.12. A bob of mass 0.1 kg hung from the ceiling. So let us consider there is a ceiling and a bob of mass 0.1 kg is hung from this. Okay, by a string of a 2-meter length. So what is the length of a string? 2 meter. Set into an oscillation. The speed of the bob at its mean position is 1 meter per second. So at this position it is your 1 meter per second. Okay, what is the trajectory of the ball if the string is cut when the bob is at one of its extreme position? So since when it bob will be in extreme position, so at extreme position velocity will be 0, so final velocity will be 0, so bob will fall down. So when you cut this, so bob will fall down. Bob will fall down. I don't think there is no other motions are there. Okay. Now second case, at the mean position. Since at a mean position it has some velocity v. So as soon as it cut by the string, so what will happen? Gravitational force will start acting and it will take in a projectile motion. So its motion will be projectile. Its motion will be projectile. Its motion will be projectile. Will be projectile. Okay. If you want to draw like diagram, so you can draw like this. Okay. So this is the diagram. I hope you have understood this question. Now I will discuss about next question, that is 4.13. So this is a very important question. A man of a mass 70 kg stand on a weighing scale in a lift is moving upward. So let us consider there is a weighing scale on the lift. So this is a weighing scale. A man is standing here. Okay, man is standing and it is in the lift system. Okay. Now what is the man of a mass of the man is how much? 70 kg. So first case, the weighing scale is lift is moving in upward direction. Lift is moving in upward direction. Okay, so what will happen? So try to make a free body diagram. So gravitational force will act downward, that is equal to mg, and mg can be equal to 70 into 10. So this is your 700 Newton, and reaction force will be there like this. So since acceleration is this 0 in this case, because velocity is constant, so can we write here reaction pace is equal to mg, as reaction force is only the only the reading in the weighing scale. Reaction force is what? It is the reading on the weighing scale. Okay, so reaction force that is equal to weight that is equal to 700 Newton. So if I will talk about mass, so reading you can take only as a mass, so there is no need to take accountability of the gravitational force, gravitational acceleration. So this will be 70 kg only. Okay. Now I will discuss about the second case. So what is the second case? If I will talk about the second case, so what they are telling in second case? In second case, a downward with a uniform acceleration of 5 meter per second. So now lift is moving downward. So downward acceleration is 5 meter per second square. So downward force is acting here is mg. Reaction force is acting upward in r. So since acceleration is 5 meter per second, so pseudo force will be how much? Ma. So ma is how much? So we can put the value later. So first of all I have to arrange this. So r plus ma is equal to mg. So r is our reading, so reading will be equal to mg minus ma. So m is common, that is equal to 70 kg into g is 10 minus 5. So we are getting 350 Newton. Sorry, this is a weight in a Newton. And if I will tell about reading, so reading in reading there will be 35 kg. Okay, reading there will be up 35 kg. Now I will show you third case. So what is third case? Now third case, what they are talking about, upward with the uniform acceleration of 5 meter per second. So here an upward acceleration is there. So definitely at first we have to take an account of weight, reaction forces R. So upward acceleration is A. So definitely downward pseudo force will be Ma. So can we write here R is equal to mg plus Ma. So m is your common, g plus A. M is how much? 70. G is 10 plus acceleration is 5. So this will be 70 into 15. So this will be 1050 Newton. So reading will be how much? So in reading we should take out the value of G, that is equal to 10. So this will be 105 kg. So this is the third reading. Now again it is the fourth case. What would be the reading if the lift mechanism failed? So if lift mechanism failed, what happened? Lift mechanism failed. So what will happen? There will be zero reading. Why zero reading? Because there will be no reaction for at all. Okay, as weighing scale is also going downward and object is also going downward, so the lift will when lift will fail, so its reading will be 0. Now I will talk about a question number 4.16. Now try to solve this question 4.14. Shows the position time graph of the particle of a mass 4 kg. What is the mass of the particle? It is your 4 kg. Okay. What is the force on the particle for a time t is less than 0? So first of all, for a time t is less than 0, so no movement is there, so force is equal to 0. For a time t is greater than 4 seconds, if I will talk about greater than 4 seconds, so from figure we can see here, at more than greater than 4 seconds, so x is constant, it means that no displacement is there, so definitely force will be 0 in this case. Now third case we will talk about its case of 0, time is greater than 0 and less than 4 seconds. So we will talk about this region. So in this region we sees that the slope is constant, it means that velocity is constant. In this case velocity is constant, and if velocity is constant, then what we can say here, acceleration is 0, and if acceleration is 0, then force will be definitely 0. So in all cases we can say from here, we can say that in all cases force is 0. Okay. Now I will talk about the second case, that is equal to impulse at a time t equal to 0 and time t equal to 4. So impulse is can be written as change in momentum. So that is final momentum minus initial momentum. Okay. So see here we have to find out the velocity at first. Okay. Between 0 to 4 seconds, if I want to find a velocity, So can we write here velocity is equal to displacement by time? So how much it is its displacement? It's a 4. Sorry, it's a 3, and time is how much? 4. So 3 by 4 meter per second, per second. Okay, so between 0 to 4, between 0 to 4, time t is equal to 0. Time t is equal to 0 to time t equal to 4 second. Velocity is equal to 3 by 4 meter per second. Okay, so if I will talk about the impulse at a time t is equal to 0, so can we write here final momentum will be what? Final momentum will be what? If I will talk about final momentum, so what it will be? So final momentum will be what? So this will be mass into final velocity minus mass into initial velocity. Since final velocity is 3 by 4, mass is 4 into final velocity is how much? 3 by 4 minus initial velocity is 0. So it will be 3 kg meter per second. So if I will talk about change in momentum at 4 second, so if I will talk about change in momentum or impulse at 4 second, so what will be the answer? Impulse at time t equal to 4 second, at a time t equal to 4 second is equal to considered as a change in a momentum, that is equal to final momentum minus initial momentum. Here what happens? Its velocity changes from initial velocity was 3 by 4 meter per second, but final velocity it is 0 because it stops. So when we see the diagram, so we can see that at 4 second an object stops. Okay, so by using this concept, so we will use here, so final velocity will be 0 minus initial velocity is with the mass. So mass is here, mass is 4 into mass is 4 into final velocity is your 3 by 4, so it is minus 3 kg meter per second. So this is the impulse at a time t equal to 4 second. I hope you all have understood now. Now I will talk about the question, next question. Okay, so I hope you have all understood. Now please think about this question. Okay, two bodies of mass 10 kg and 20 kg respectively kept on the smooth horizontal surface. So let us consider this is a smooth horizontal surface. So two objects, suppose this is your 10 kg mass, 10 kg mass. So and another object, it is 20 kg, right? It's 20 kg, and both are tied with the string. Okay, and the horizontal surface at the end of the light string, a horizontal force of 600 Newton is applied at A and B. So let us consider at A and this is your B. So if horizontal force, suppose in this direction 600 Newton force is applied, then what is the tension in the string in each case? So let us consider, let us use free body diagram of A. So if I will use free body diagram of A, so what will be there? So let us consider this. Since it is a smooth horizontal, so due to weight it is your 100 Newton acting downward, there is a reaction force, or both are equal and opposite, so they will cancel out each other. Now 600 Newton force is being applied, force is equal to 600 Newton in this direction, and in this direction tensions is there. Is there any other forces are there? Definitely, if I am pulling this object, so there will be acceleration in this direction, so what will be the acceleration? So pseudo force will be mass into acceleration. So this is your 10 into acceleration. Okay, so So before doing this, we should find out what is the acceleration of the body. Okay, so how you will find acceleration of the body? Since both, if I will take total mass, so total mass will be how much? Total mass will be equal to 20 plus 1 10 kg, that is equal to 30 kg. Okay, so if I will talk about acceleration, if anywhere if this force will be acting, so acceleration will be equal to force by mass. So force is how much? Force is 600 by the mass is 30 kg, so this will be 20 meter per second square. Okay, total mass is how much? 30 kg, and total force is 600, so this will be 20 meter per second. Now I will talk about the acceleration of this particular object. So if I will talk about the acceleration of this particular object, so acceleration will be in which direction? So definitely acceleration will be in this direction, and this is equal to 20 meter per second square. So pseudo force will act in this direction. So pseudo force F pseudo will be equal to mass into acceleration. So that is mass is how much? Mass is 10 kg of this object into acceleration is 20. So if I will equate this, then what will happen? What will happen? See here, I have taken pseudo force two times, so I should not take this as a two time. See this is what I am talking about. This is a pseudo force only. Okay, so just this is the pseudo force. This both are same. So for an equilibrium condition, total force will be equal in horizontal direction. So this is your minus 600 plus tension plus mass into acceleration, that is equal to 10 into 20. So this must be equal to 0. So from here tension will be equal to 600 minus 200. So this is a 400 Newton. I hope you have understood now. Tension in this rope is 400 Newton. Now the same case is that when an object is here and another 20 kg object is here and string is connected, but the force is acting in this direction, that is 600 Newton. Okay, so since it has mass to 20 kg, it has mass 30 kg, 10 kg, so acceleration will be how much? So acceleration, if I will talk about acceleration, so acceleration will be how much? So acceleration you can find out easily. Acceleration is equal to 600 divided by total mass m1 plus m2, that is equal to 600 by 30. So that is same acceleration, 20 meter per second square. Okay, now I will talk about the part B. Since it is we have already discussed about part A, and this is a part B, or part B object is there and tension is acting in this direction and the force is acting 600 Newton, acceleration being in this direction. So there will be pseudo force, F pseudo will be equal to mass into acceleration. So now is there any horizontal force is there? No. So can we write here minus pseudo force minus tension is equal to, sorry, minus plus 600 is equal to 0. So from here we can write here tension is equal to 600 minus pseudo force, and 600 minus pseudo force is how much? Pseudo force is your mass is how much? 20 into acceleration is 20. So tension in this case is 400. Sorry, tension in this case is, this is your 400, this is your 600. So how much it is coming? So 600 minus 400, so this will be 2200 Newton. So I hope you have understood now. Now when an object when a force is acting on B, so tension becomes 200. When a force is acting on A, tension becomes 400. It means that tension increases when the mass, this opponent mass is increased. Okay, I hope you all have understood now this question. Thank you everyone.